You are lost. Not the kind of lost where you pull out your phone and wait 3 seconds for a blue dot to tell you where you are. Actually lost. It is 40,000 years ago, you are somewhere in what is now Central Australia. And in every direction there is nothing but flat, dry, featureless earth stretching to the horizon. No roads, no signs, no landmarks you can name. If you walk the wrong direction, you will die. Not eventually. Soon. There is one water source within a day's walk, and if you miss it, the next one is 4 days further, and you will not survive 4 days without water in this heat. But you are not panicking. Because inside your head, right now, there is something no other animal on this planet has ever built. A map. Not drawn on paper, not carved into stone. A map made of songs, stories, and memories, so precise that you can navigate 1,000 kilometers of open desert by singing the right verses in the right order. That map is older than writing, older than cities, older than farming, and possibly older than language itself. So how did that happen? How did a species of primate that started out navigating the same way every other animal does, by remembering where the food is, end up inventing a technology so powerful that it literally redrew the surface of the Earth? The answer starts inside your brain. And it starts long before humans existed. In 1971, a neuroscientist named John O'Keefe at University College London was recording electrical activity from neurons in a rat's hippocampus when he noticed something strange. Certain neurons only fired when the rat was in a specific location, not when it saw something specific, not when it smelled something, just when it was there, standing in that particular spot. He called them place cells. He had just discovered that the brain does not experience space the way you experience a photograph. It builds a map, a real, functioning, constantly updating internal map of where you are, where you have been, and where things are in relation to each other. 34 years later, in 2005, two Norwegian neuroscientists named May-Britt Moser and Edvard Moser found the next piece. Working at the Norwegian University of Science and Technology, they discovered neurons in the entorhinal cortex that fire in a perfect hexagonal grid pattern as an animal moves through space. They called them grid cells. If place cells are the pins on your mental map, grid cells are the coordinate system. The graph paper underneath. Together, they give your brain something no GPS engineer has ever improved upon. A self-updating three-dimensional spatial model of the world around you, running constantly, without batteries, without satellites, without a single line of code. In 2014, O'Keefe and the Mosers shared the Nobel Prize in Physiology or Medicine for discovering what the Nobel Committee called the brain's inner GPS. That system is not unique to humans. Rats have it, birds have it, bees almost certainly have a version of it. The psychologist Edward Tolman proved all the way back in 1948 that rats build what he called cognitive maps, flexible internal representations of space that let them find shortcuts they have never taken before. Every animal that moves through space has some version of this hardware. The difference is that humans, at some point, did something no other animal has ever done. We took the map out of our heads and put it on a surface. Think about what that actually requires. You have to take three-dimensional space, an environment you move through with your body, and flatten it into a two-dimensional image that someone else can read. You have to decide what matters and what does not. You have to agree on symbols. North is this way. Water looks like this. That mountain is represented by this shape. You have to translate a lived experience into an abstraction. That leap from experiencing space to representing space is one of the most important cognitive transitions in the history of our species. Once you can put a map on a surface, you can share it. You can teach it. You can hand it to someone who has never been where you have been and give them the ability to go there without you. So when did humans first do that? The honest answer is that we do not know. And the reason we do not know is that the earliest maps were almost certainly drawn in dirt, scratched into sand, or described with gestures and words, none of which survive. But the oldest physical objects that might be maps are far older than most people expect. In 1962, archaeologist Bohuslav Klima was excavating a site called Pavlov in the Czech Republic when he found a mammoth tusk fragment, roughly 25,000 years old, covered in engraved lines. Wavy lines, arcs, circles. Klima interpreted it as a topographic map of the local landscape, showing the meanders of the DJ River, the slopes of the Pavlov Hills, and possibly the location of a settlement. 25,000 years old. During the last glacial maximum, when ice sheets covered most of northern Europe. And they were making maps. Or maybe they were not. That is the problem with prehistoric maps. You are looking at lines on a surface and trying to decide whether those lines represent the real world or something else entirely. A similar debate surrounds a wall painting at Çatalhöyük, a Neolithic settlement in Turkey dating to roughly 6,200 BC. When archaeologist James Mellart excavated it in the 1960s, he declared it the oldest map in the world. A bird's-eye view of the town with a twin-peaked volcano erupting in the background. Then, in 2006, archaeologist Stephanie Meese argued that what Mellart saw as a volcano was actually a leopard skin, a decorative motif common at the site, and that the map was just a geometric pattern. The consensus is still split. That split tells you something important. A map is only a map if someone can read it as one. Without the cultural context to decode the symbols, it is just lines on a wall. But there is one candidate that most researchers agree is genuinely a map. In 1993, a team led by archaeologist Pilar Utrilla at the University of Zaragoza found an engraved stone block in a Bounds cave in Navarra, Spain. It is roughly 13,660 years old. Utrilla spent 15 years studying it before publishing her findings in 2009. The engraving shows what appears to be a mountain, rivers, ponds, and possible routes through the landscape. It matches the actual terrain around the cave. Someone sat down, studied the landscape around their home, and scratched a simplified version of it onto a rock so they could plan a hunt or explain a route to someone else. 13,660 years ago. No writing, no cities, no agriculture. And someone was already making maps. Now here is where the story of maps splits into two completely different paths that would not reconnect for thousands of years. Because in some parts of the world, humans figured out how to put maps on physical surfaces, clay tablets, papyrus, stone. And in other parts of the world, they figured out something arguably more impressive. They built maps that existed entirely in memory and were transmitted through songs. The Aboriginal peoples of Australia developed what are now called songlines, or dreaming tracks, navigational systems encoded into songs, stories, and ceremonies that describe the landscape in such precise detail that a person who has never visited a place can navigate it by singing the correct verses in the correct sequence. Specific landmarks, water sources, rock formations, and seasonal food sources are all embedded in the lyrics. The landscape itself functions as a memory palace, with each feature triggering the next piece of the song. Astrophysicist Ray Norris has documented how some songlines encode star positions for celestial navigation. Scholar Lynn Kelly has compared the system to the ancient Greek method of loci, and argued it is one of the most sophisticated mnemonic systems ever devised. These songlines are estimated to be at least 10,000 years old. Some researchers believe they stretch back 60,000 years to the earliest human settlement of Australia. 60,000 years. That would make songlines not just the oldest maps, but one of the oldest continuous intellectual traditions in the history of our species. On the other side of the world, the Marshallese people of Micronesia built something different but equally remarkable. Stick charts. Frameworks of pandanus root or coconut midribs tied together with fiber, with cowrie shells attached to represent islands. The curved sticks showed ocean swell patterns, how waves refracted around atolls, bounced off underwater ridges, and interfered with each other in predictable ways. They were not carried on voyages. They were teaching tools, studied on land before sailing, used to train navigators to feel the ocean's invisible architecture with their bodies. 3 types existed: the matang, which taught general principles; the meadow, which showed a specific island group; and the rebelib, which mapped an entire chain. And the Polynesian navigators who settled the vast triangle from Hawaii to New Zealand to Easter Island took the concept even further. They had no instruments at all, no compass, no astrolabe, Nothing. They navigated using what modern researchers call a star compass, a memorized mental map of where roughly 220 stars rose and set on the horizon throughout the year. A navigator would steer toward a specific star as it rose in the east, and as that star climbed too high to be useful for holding a bearing, he would shift to the next star rising at the same point. When the sky was overcast, he read the ocean itself, feeling the direction and rhythm of deep ocean swells through the hull of the canoe. The flight patterns of birds told him how far he was from land. Terns rarely fly more than 40 kilometers from shore. The color of clouds told him what was beneath them. A greenish tint on the underside of a cloud often meant a shallow lagoon below. Training took decades, beginning in childhood, and the knowledge was passed down through songs and chants, not textbooks. In 1976, a double-hulled voyaging canoe called the Hokulea sailed from Hawaii to Tahiti, roughly 4,000 kilometers, using nothing but traditional Polynesian wayfinding. The navigator was Maupiailug, a master wayfinder from Satawal in Micronesia, one of the last living practitioners of the art. He guided the canoe across open ocean with no instruments, no charts, no GPS. He read the stars, the waves, and the birds. He arrived within sight of Tahiti. That voyage proved that the ancient Polynesians really could have settled the Pacific the way the oral traditions said they did, by reading the ocean like a map. Think about what these systems, songlines, stick charts, star compasses, tell you about the invention of maps. None of them looks like what you picture when you hear the word map. No paper, no grids, no compass roses, but all of them are maps. All of them encode spatial information in a format that can be shared and taught. All of them allow someone to navigate terrain they have never personally visited. The technology of the map is not the paper. It is the idea. The idea that you can take the shape of the world and compress it into a form that fits inside a human brain or a human hand. Now, the physical maps, the ones most people think of when they think about cartography, those appear in Mesopotamia, modern-day Iraq. The oldest surviving physical map that nearly everyone agrees is genuinely a map is a small clay tablet about the size of your palm, found at Gasur, later called Nuzi, in modern-day Iraq. It dates to roughly 2300 BC, the Akkadian Empire period. It shows hills, rivers, and a plot of land identified as 354 IQ, about 300 acres, belonging to a place called the Fortress of Ebla. It is a property record, a deed with a picture. It sits in the Semitic Museum at Harvard, and it tells you something about the original purpose of maps that is easy to forget. The first maps were not made for exploration. They were made for ownership. That is not a small distinction. Think about it. The moment you draw a map that shows where your land ends and your neighbor's land begins, you have created a legal document, a claim, a boundary. The map is no longer just describing the world, it is deciding who owns it. And that connection between maps and power would only grow stronger over the next 4,000 years. But Mesopotamia also produced the oldest known attempt to map the entire world. A small clay tablet, about 12 centimeters by 8 centimeters, inscribed in Akkadian cuneiform, now catalogued as BM 92687 in the British Museum. Scholars call it the Babylonian Imago Mundi. It was excavated at Sippar in modern-day Iraq and dates to roughly the 6th century BC, though it may be a copy of a map originally drawn as early as the 9th century BC. It shows the world as a flat disk. Babylon sits at the center, bisected by the Euphrates River. Surrounding the landmass is a ring of water, labeled the Bitter River, their word for the ocean. Beyond the ocean, 8 triangular regions point outward like rays, representing distant, mythological lands where strange creatures lived and heroes once traveled. It is not a practical map. You could not use it to find anything. But it is a cosmological statement, a civilization saying, this is where we are in the universe, this is how the world is organized, and we are at the center of it. Every civilization that has ever drawn a world map has put itself at the center. The Babylonians did it first. The Egyptians took it further. Around 1150 BC, a scribe named Amenachte, son of Ipui, created what is now called the Turin Papyrus map, the oldest known topographical and geological map. It was commissioned by Pharaoh Ramesses IV to plan an expedition to the Wadi Hammamat in the eastern desert between the Nile and the Red Sea. It shows roads, hills, the locations of gold mines and stone quarries, all drawn with different colors to indicate different types of rock. This is not a symbolic map. This is a practical, functional, you need this to get the job done working document. It sits in the Egyptian Museum in Turin, Italy, and it looks more like a modern geological survey than anything a 3,000-year-old civilization should have been able to produce. But the Greeks changed everything, because the Greeks did something nobody before them had attempted. They tried to map the entire world. Around 550 BC, a philosopher named Anaximander, working in the city of Miletus on the coast of modern Turkey, is credited with creating one of the first maps of the known world. It was circular, showing Europe, Asia, and Africa surrounded by ocean. No copy survives. But the idea that you could represent the whole Earth on a single surface was revolutionary. A century later, around 240 BC, a librarian named Eratosthenes, working at the Library of Alexandria, did something that should make you sit up. He calculated the circumference of the Earth. His method was elegant. He knew that at noon on the summer solstice, the sun was directly overhead in Siene, modern Aswan, casting no shadow. In Alexandria, roughly 800 kilometers to the north, a vertical pole cast a shadow, showing the sun was about 7.2 degrees from vertical. 7.2 degrees is 1/50th of a full circle. So he multiplied the distance between the two cities by 50 and got a number that is within about 2% of the actual circumference of the Earth. 2%. 2,200 years ago. With a stick and a shadow. No satellites, no lasers, a stick and some math. And then Claudius Ptolemy, around 150 AD, wrote a book called Geographia that would shape mapmaking for the next 1,400 years. He assigned latitude and longitude coordinates to roughly 8,000 locations across the known world. He developed map projections, mathematical methods for representing a curved surface on a flat page. His system was flawed. His estimate of Earth's circumference was about 30% too small. That error, 1,300 years later, would convince a Genoese sailor named Christopher Columbus that he could reach Asia by sailing west across a much smaller ocean than the one that was actually there. Ptolemy's mistake was still shaping the world more than a millennium after he made it. Meanwhile, in China, a Jin dynasty official named Pei Shu was independently developing the science of cartography. Around 267 AD, he established the 6 principles of cartography: proportional scale, directional orientation, road distance, elevation, angles for winding routes, and corrections for curves versus straight line paths. These are the same principles any modern cartographer would recognize. Pei Shu developed them with zero knowledge of Greek cartography. Different continent, different language, different mathematical tradition. Same problem, same solution. The map, like the bow or the boat, is an invention that converges. In 1136 AD, Chinese cartographers carved the Yuji-2, the map of the tracks of Yu, onto a stone stele. It used a strict rectilinear grid, where each square represented 100 li, roughly 50 kilometers. The coastline of China on this map is accurate enough that you could overlay it on a modern satellite image and recognize the shape. This is 800 years before the age of exploration, 800 years before European maps would achieve anything close to this precision. Now here is a pattern interrupt that matters for the rest of this story. Why is it that when most people think of the history of maps, they think of Europe? The answer is not that Europe was first. It was not. It is not that European maps were better. For most of recorded history, they were worse. Medieval European maps, the famous Mapae Mundi, were theological documents, not navigational ones. The Hereford Mappa Mundi, made around 1300 AD by a cleric named Richard of Haldingham, is the largest surviving medieval world map, roughly 1.6 meters across. Jerusalem is at the center. Biblical events are scattered across the surface. Mythological creatures inhabit the edges. It is beautiful. It is historically fascinating. It is absolutely useless for getting anywhere. At the same time, in 1154 AD, an Arab geographer named Muhammad al-Idrisi completed the Tabula Rogeriana, commissioned by King Roger II of Sicily. It was one of the most accurate and detailed maps of Eurasia and North Africa that had ever been created, drawn with south at the top, synthesizing Greek mathematical geography with contemporary Islamic scholarship and empirical reports from travelers who had actually been to the places being mapped. It was engraved on a silver disc. While European maps were placing dragons in Africa, al-Idrisi was mapping its actual coastline. But there was one type of European map that actually worked: the Portolan chart. These appeared in the Mediterranean around the late 1200s, and the oldest surviving example, the Carta Pisana, dates to roughly 1290 AD. Portolan charts were made by and for sailors. They showed coastlines with startling accuracy, drawn on animal skin, covered in a web of intersecting straight lines called rhumb lines radiating from compass roses. A navigator could lay a straight edge between two ports, read the bearing from the nearest rhumb line, and sail that heading. Port names were written perpendicular to the coastline, in black for ordinary harbors, and red for major ones. The interiors of continents were left blank. Sailors did not care about the interior, they cared about the coast. Nobody knows exactly how these charts were first made. They appear in history fully formed, with no clear predecessor. And their coastal outlines are so accurate that scholars have spent decades trying to explain how 13th century sailors could have produced them. The most likely answer is that they evolved from Portolani, written sailing directions describing bearings and distances between ports accumulated over generations of voyages. Someone took those written directions and plotted them geometrically. The result was the first truly practical European map. The reason most people think of European maps first is not because Europe mapped the world first or best. It is because European maps eventually became the maps that conquered the world. And that is a story about power, not accuracy. In 1507, a German cartographer named Martin Waldseemüller published a map that did something no map had ever done before. He labeled the new land mass across the Atlantic with a name: America, named after Amerigo Vespucci, not Columbus. One word on one map, and an entire continent had a name it would never lose. That is how much power a map carries. It does not just describe reality, it names it, it defines it. It decides what exists and what does not. In 1569, a Flemish cartographer named Gerardus Mercator published a map projection that solved a practical problem for sailors. On a Mercator projection, lines of constant compass bearing appear as straight lines, meaning a navigator could draw a straight line between two ports and follow that compass heading without adjustment. Brilliant for navigation. But the projection has a distortion that would quietly reshape how the world sees itself. It inflates landmass sizes as you move away from the equator. On a Mercator map, Greenland, which is about 2.17 million square kilometers, looks roughly the same size as Africa. Africa is 30.4 million square kilometers, 14 times larger. For 450 years, the most used map in the world has been making Europe and North America look bigger than they are and making Africa and South America look smaller. That is not a conspiracy, it is a math problem. But the effect on how people imagine the world is real and measurable. Then came the moment when maps stopped being art and became engineering. In the 1740s, a French astronomer named César Francois Cassini de Thury, third generation of the Cassini family to direct the Paris Observatory, began work on the first systematic national survey ever attempted. The Carte de Cassini. His method was triangulation. You pick 2 points, measure the distance between them precisely, then use geometry to calculate the position of a third point visible from both. You use those new points to calculate more points and more until you have a network of triangles covering the entire country. His surveyors erected stone markers across France, took thousands of astronomical observations, and produced 182 map sheets at a scale of 186,400. 4 generations of the Cassini family and nearly 70 years of work went into finishing it. The final sheets were not published until 1815, but the result was the first time any nation had a geometrically accurate picture of its own territory. When Louis XV saw an early draft showing the true shape of the French coastline, he reportedly complained that the survey had cost him more territory than any war, because the old maps had made France look bigger than it was. The Cassini map later became a tool of the French Revolution. The new government used it to redraw France into 83 departments. A map made by royal astronomers became the instrument for dismantling the monarchy that paid for it. And speaking of power, here is perhaps the starkest example of a map reshaping reality. In 1884, representatives from 14 European nations gathered in Berlin for a conference hosted by German Chancellor Otto von Bismarck. They were there to divide Africa among themselves. They drew borders on maps, straight lines, geometric shapes, rivers chosen as boundaries not because they made sense on the ground, but because they were visible on a map from thousands of kilometers away. The Maasai were split by the border between Kenya and Tanzania. The Somali people were fragmented across 3 modern countries. These borders, drawn by men who had never visited the places they were carving up, are still the borders of Africa today. A map made in a conference room in Berlin in 1884 is still deciding who lives in what country, 140 years later. And then the map left the surface of the Earth entirely. On October 4, 1957, the Soviet Union launched Sputnik, the first artificial satellite. At the Johns Hopkins Applied Physics Laboratory, 2 physicists named William Geer and George Wayfinders noticed something. As Sputnik passed overhead, the frequency of its radio signal shifted, higher as it approached, lower as it receded. The Doppler effect, they realized that by measuring that shift, they could calculate the satellite's orbit. Then someone asked the reverse question. If you knew the satellite's position, could you use the same Doppler shift to calculate the position of someone on the ground? You could. The U.S. Navy built the first satellite navigation system, called Transit, to help nuclear submarines pinpoint their locations without surfacing. In 1973, the Department of Defense began work on the Global Positioning System. The first experimental GPS satellite was launched on February 22, 1978. By the 1990s, the constellation was complete, 24 satellites orbiting at roughly 20,200 kilometers above the Earth, each broadcasting a time signal so precise that a receiver on the ground could calculate its position to within a few meters. Meanwhile, starting in 1960, a classified CIA program called Corona was putting cameras on satellites and photographing the Earth from orbit. The film was ejected in capsules that parachuted back through the atmosphere and were caught midair by specially equipped aircraft. It sounds absurd. It worked. Over 12 years, Corona satellites photographed every square kilometer of the Soviet Union, producing imagery so detailed that analysts could count individual aircraft on runways. When the program was declassified in 1995, its archive of over 800,000 images became a resource for archaeologists, climate scientists, and cartographers. For the first time in history, maps had been made by machines that had actually seen the entire surface of the planet from above. But here is where the story comes full circle. Back to the brain, back to where we started. In 2020, neuroscientist Louisa Dominy and researcher Veronique Bobat at McGill University published a study examining what happens to the human brain. When you outsource navigation to a GPS device, they found that extensive GPS use physically reduces gray matter volume in the hippocampus, the exact brain region where John O'Keefe discovered place cells in 1971. The mechanism is straightforward. When you navigate using your own spatial memory, you engage the hippocampus, building and maintaining your cognitive map. When you follow turn-by-turn GPS directions, you bypass it entirely, relying instead on the striatum, a more automatic, habit-based system. Use it or lose it. People who rely on GPS most show measurably smaller hippocampi and worse spatial memory over time. Think about what that means. For at least 13,000 years, and possibly 60,000, humans have been building, refining, and transmitting maps, pushing the spatial capabilities of the brain to extraordinary levels. Aboriginal Australians encoded entire continents into memory through song. Polynesian navigators crossed thousands of kilometers of open ocean reading wave patterns. Greek mathematicians calculated the size of the Earth with a stick. And now, in a single generation, we are outsourcing all of it to a device in our pocket. The map went from inside our heads to a clay tablet, to paper, to a screen, and now the screen is slowly replacing the map inside our heads. The tool we invented to extend our spatial cognition is now replacing it. So, how did humans invent maps? Here's the answer. Maps were not a single invention. They were the same invention, made over and over, on every continent, by people who had no knowledge of each other whenever one condition was met. A human brain needed to communicate spatial information to another human brain that was not there. That is it. That is the whole engine. Every map ever made, from a 25,000-year-old mammoth tusk in the Czech Republic to the Google Maps tile loading on your phone right now, exists because someone needed to say the water is over there to someone who could not see it. The songlines, the stick charts, the clay tablets, the papyrus scrolls, the Portolan charts, the Mercator projections, the satellite imagery, all of it is the same impulse. Take what I know about where things are and give it to you in a form you can use. The probability that the fundamental human capacity for spatial representation, the biological hardware, evolved once in Africa and was carried everywhere by migrating Homo sapiens is roughly 95%. The probability that the externalization of that capacity onto physical surfaces was independently invented multiple times is effectively 100%. It happened in Mesopotamia, in China, in Australia, in Micronesia, in Egypt, in Greece, in the Americas. No one culture invented the map. The map invented itself, everywhere, because the brain that builds cognitive maps was always going to find a way to show them to someone else. Tonight, somewhere, a person is opening an app on their phone and typing in an address. A blue dot will appear, a route will be drawn. They will follow it without once thinking about the 60,000-year chain of human ingenuity that put that blue line on that screen. And somewhere else, an elder is singing a song that describes a river they have never seen, teaching a child to find water in a desert by memorizing a melody, using the same hippocampal hardware that John O'Keefe found firing in a rat's brain in a London laboratory in 1971. The technology has changed, the principle has not, someone knows where the water is, and they are finding a way to tell you.